Good morning, everyone, and welcome back from your break. Today, I unexpectedly couldn't make it in, so we still have stuff to do, so I'm leaving this video. Luckily, today is going to be kind of an easy day for you guys. It's just going to be notes. So, first thing we're going to do is we're going to go over our warm-up. Please make sure that you picked up the warm-up that says geometry at the top. All of the warm-ups look the same, so it's easy to mix them up. So make sure yours says geometry. Okay, so the Tuesday problems, number 1, simplify the radical, square root of 96. So if you're using the calculators there in class, the black calculators, if you type this in, it's just going to give you the answer. But if you notice, I also have yellow calculators in the classroom because I am going to take those black calculators away. We need to know how to do this on our own. The way you do this is you get the number inside, so 96, and we're going to break it down to the smallest numbers that we can. So I know that 96 is 2 times 48. And then 48 can be broken down to 2 times 24. And then I'm just going to keep doing that until I can't anymore. So 2 times 12, 2 times 6, 2 times 3. And after that, that's the smallest I can make it go. So square root of 96, it's like saying square root of all of those numbers. 2 times 2 times 2 times 2 times 2 times 3. 1, 2, 3, 4, 5 2s and 1 3. Then what you're doing is you're looking for pairs since this is a square root. So here's a pair of 2s, here's another pair of 2s, but then each of these numbers are just alone. So both of these numbers that are circled would go to the outside. So 2 times 2, that gives us 4. And then the numbers that weren't circled stay on the inside, but we multiply. 2 times 3 is 6. So simplifying this would be 4 square root of 6. Okay, and then number 2, solve for x. This one is fairly easy. You just have to cross multiply. So it would start with 12 times 12 equals, and then cross multiply the other way, 16 times x. We know that 12 times 12 is 144. So 144 equals 16x. And then we're going to divide both sides by 16. And that will get us x equals, I'm going to put this in the calculator, 9. Okay, so those are the warm-ups for today. Okay, so we're officially starting Unit 6. So the white paper that you picked up, it should say Pythagorean Theorem at the very top. Unit 6 is all about right triangles. So I know we've been talking about triangles for a while now, but these are specifically going to be right triangles only. That means that all the triangles that we're looking at are going to have that little square in one of the corners. So starting with Pythagorean Theorem, you guys learned this in middle school. We even did this before the break, so today should be easy. Is used to find the missing sides of a right triangle. Of a right triangle, so it only works with right triangles. Sides A and B, so you see how it's labeled here? A and B are called the legs of the triangle. And then side C is called the hypotenuse. Hypotenuse is always going to be across from that right angle, so wherever the right angle is, whatever is across from it will be what we're trying to find most of the time. Okay, and then for any right triangle, so what is the actual Pythagorean theorem? It is a squared plus b squared equals c squared. So notice whatever the hypotenuse is, that's the one that's by itself. Okay, so we're going to do a few examples We're not going to do them all because there are a lot of examples, but we're going to do some on the front and on the back. So for the ones on the front, it says find the value of x and round each number to the nearest tenth. So that means that we're going to get some decimals. We're going to be rounding to just 1 decimal point. Okay, so for the first one, we have 8, 13, and x. So it's important that we figure out which one is the hypotenuse. So wherever the right angle is, so here's our right angle, when you go across from it, that has to be C. And then the other two can be however you want. So I'm just going to go in this order. So when I write out my Pythagorean theorem, I'll have 8 squared plus 13 squared equals x squared. Okay, well, I know that 8 squared is 64 and 13 squared is 169. Okay, and then when I add those together, I get 233. Okay, but I want just regular x, not x squared, so we're going to square root. So square root of 233, when you type it into the calculator, it's just going to stay like that. But that's like an exact answer. They wanted us to round to the nearest tenth. So if you press Control Enter, you should get 15.3. Okay, so why don't we go ahead and do the odd problem? So let's now look at number 3. So again, find your right angle. And then when you go across from it, that has to be C. The other two can be however you want. So I'm going to say this is A and this is B. So I have x squared plus 7 squared equals 9 squared. Okay, so I know that 7 squared is 49 and 9 squared is 81. I'm going to subtract 49 from both sides. So then now I get x squared equals 32. And then we're going to take the square root of both sides. X equals, if you type it into the calculator, it's going to tell you 4 square root 2, which is not wrong, but we want the decimal approximation. So Control Enter, 5.7. Okay, number 5. This is where it starts to get a little bit interesting. So this is an isosceles triangle. See how 2 of the sides are the same? Okay, but x is the height of that triangle. So you can think of it as just this side. Okay, but in order to do just that side of the triangle, we need to know what that bottom is. So if all the way across is 22, and this is isosceles, these two are the same, that means it's split exactly in half. So that would be 11 and 11. So now, if this is my right angle, when I go across from it, that has to be C. And then now my other two sides can be however I want. So I would have 11 squared plus x squared equals 24 squared. Okay, so 11 squared is 121. 24 squared is 576. Let's subtract 121 from both sides. X squared equals 455. And then we square root. X equals 21.3. Okay, let's skip number 7 for now. Let's now turn to the back. actually, I think we should go now to the application. So we have 4 word problems. Let's do 2 of these word problems and then we can be done from here. Okay, so let's keep to the pattern. We were doing odd numbers, so let's do odd numbers. Let's look at number 11. Kurt is building a rectangular deck. Okay, so I'm going to draw out what they tell me so far. So rectangular deck, here's a rectangle. If the dimensions of the deck are 10 feet by 23 feet, so this is 10 feet, this one's 23 feet. What is the length of the diagonal of the deck? So diagonal means like from bottom corner up to the top corner. So they're wanting us to find that. And because we don't know what it is, we're just going to put an X there. Okay, so the thing about rectangles is they have right angles for all of them. So I know that this makes it into a right triangle. Since this is where the right angle is at, across from that has to be the hypotenuse. So C is going to be the X, and then the other 2 can be however you want them to be. So I'm going to do 10 squared plus 23 squared equals X squared. So this is 100. 23 squared is 529. Okay, adding those together, that's 629. So then we would take square root of both sides. And X equals 25.1. And since they're measuring in feet, let's go ahead and label that. So the diagonal would be 25.1 feet. Okay, and then last one, let's do number 13. A 31-foot support wire is attached from the top of a 25-foot telephone pole to a point on the ground. How far from the base of the pole does the wire meet the ground? Okay, so here's the ground. So I'm just going to do like a horizontal line. And there's a telephone pole coming out from the ground. So there's the telephone pole. The problem tells us that the telephone pole is 25 foot. Okay, at the beginning it said there's a 31-foot support wire. So that means that there's like a wire attached to the top going towards the ground. So that's the wire. And they're saying that that wire is 31 feet. Now the question says, how far from the base of the pole, so the base of the pole is the bottom, does the wire meet the ground? So they want to know what this bottom side is right here. So then that's what we're trying to find. I'm going to label it as X. Okay, so think about real life. When you have a pole coming up from the ground, it's not just like slanted. However, if it's a good like construction worker, they make it perpendicular to the ground. So there's our right angle. So if that's our right angle, then across from that, that has to be C. And then the other 2 can be A and B. Okay, so we have 25 squared plus X squared equals 31 squared. 25 squared is 625. 31 squared is 961. Let's subtract 625 from both sides. X squared equals 336. Then we square root. And X equals 18.3. And this one was also measuring in feet. So the base of the pole and then where the wire meets the ground, that right there is 18 feet. Okay, and then that's it. So Pythagorean Theorem, super easy. Tomorrow we're going to keep reviewing it. I should hopefully be back tomorrow. So make sure that all of this is filled in. Make sure that you keep it somewhere. So you should have a binder for this class. And I will see you guys tomorrow.